Welcome to Math in a Box with Susan Johnsey. In this lesson we are going to study proofs. As you can see, I have a diagram here. It's a diagram of angles. There are three angles that I have labeled. There's actually several angles in the diagram though. But you can see that I have three of them labeled. The first one, X, O, Y, I have actually labeled him angle 1. That just gives me an easier way to refer to him. He can be called angle X, O, Y, or we can call him angle 1. I also have angle 2 labeled. That's actually angle Y-O-L. Y-O-L is angle 2. And then I have angle 3. That's L-O-P. But if you'll look at the marks here, these are called arcs. I have that angle indicated, and that angle would be considered Y-O-P. And then this little arc, smaller arc here, that's angle X-O-L. Now there are still other angles, but those are the ones that we're going to talk about. The three that I have labeled with a number, and the two that I have labeled with arcs. That just hopefully helps you see them all better. Now in this proof we are going to prove that angle 1 is congruent to angle 3, or rather equal. Let me explain the word equal and the word congruent. I'm going to talk about properties now here for a minute. In algebra we have properties that talk about equality, and in geometry we have properties that talk about congruence. With equality we are talking about the numbers, the real numbers. So anytime I use the word equality and I want to talk about these properties, I will be talking about the real numbers. The numbers that you and I use all the time. If I want to talk about line segments, angles, or even triangles, squares, parallelograms. If I want to talk about geometry figures, then I will use the word congruence. So they're a little bit alike because they do mean that the two things are equal. If I say two line segments are congruent, if I say two triangles are congruent, then that really means the triangles are exactly the same. They would fit right on top of each other. Or we can do the same thing with two angles. If an angle measures 30 degrees and another angle measures 30 degrees, then the angles are said to be congruent. Now the measures of the angles are equal because that's numbers. 30 equals 30. So when we use the word equal, we'll be saying we're talking about numbers. When we use the word congruence or congruent, we'll be talking about the actual figures. Alright, now then, we have several properties listed here. Let's start with the addition property. You know this one from algebra, but you are going to learn to use it in geometry. We can use it with geometry class. If two numbers are equal, if A is equal to B, or if 5 is equal to 5, 3 is equal to 3. I'm just saying A equals B. Those are two numbers that are equal. And let's say I have two other numbers that are equal. Let's say C is equal to D. Now right now I'm just going to use the C, so just hang on to the D, or just forget about him for a few minutes. If I know that A equals B, and I decide to add, because we're talking about the addition property, if I decide to add A and C, that means I took this C and added it to the A, then guess what? In order to still have an equation, do you know that word? We would also have to take the B and add C to it. Because I want these two expressions that I started with, A equals B, to stay equal. So if I add C on the left, I will have to add C on the right. That's the words left and right here. I'm talking about the left side of the equal marks and right to the right of the equal marks. So I'll say those quite often, left and right. And I'm talking about what's to the left of the equal or what's to the right of the equals. So if I add C on the left, I have to add C on the right. And since C and D are actually equal, I could write D here instead. I could add C on the left and add d on the right, since c and d are equal. The subtraction property is the same idea. I will start with, say, x equals y. And let's just take the letter p. If I subtract p from the left side, then I must also subtract p from the right side. And of course, if I say p is actually equal to q, another number, if p and q are equal, then I could, instead of putting a p right here, I could subtract q. That's our subtraction property. We also have a multiplication property, a division property. These are both very similar to the add and subtract. There is one thing with division property. The second number that I made up, or the third number, that I made up cannot be 0. So for the division property, if you have a equals b, and then you have c or you have d, you have to also say, hey, c cannot be 0. Because we can't divide with 0. Did you know that a divided by a 0 is undefined? Hopefully you learned that in Algebra 1. Anyway, I can put c here only if I know that the c is not 0. So we put that there. Now here is a new property, substitution property. You have probably never heard of that property, but you have been using it all the time. You've actually used that property ever since first grade. That property replaces. It replaces equals. I'm going to run out of room here, but we'll try. All right, let's take 5 plus x equals y. That's an equation. 5 plus x equals y. Now, we can't really do anything with that algebraically, but if I were to tell you something else, and if I tell you that y is 7. Now, I know you're going to try and figure out x, right? But I'm not asking you to do that. We're not doing algebra problems right now. We're trying to learn what this substitution property means. What did I tell you? It says it can replace equals. What does that mean? It means that if I come back over here to this equation, 5 plus x, that I can replace this y. I can take it out and replace it with what it's equal to, a 7. That's all I wanted you to do. That is the substitution property. You can replace things that are equal. Now let's look at something, though, that's a little more geometry. I made us a little more room here. Let's look at this substitution property again. Let's say that we have angle A, that's the angle symbol, plus angle B. Two angles, we're adding the two angles together, and we're going to say that they equal 30 degrees. That's a little degree mark. But also I'm going to tell you something else. And I'm going to tell you that angle A equals angle C. Okay, now we're going to use the substitution property with these two equations. We know that we can replace things. We can replace. So what I'm going to do is I'm going to take the first equation that I wrote, but instead of writing the A, I'm going to replace it with what angle A is equal to. Angle A is equal to C. So I'm going to write an angle C here. I'm writing angle C plus angle B equals 30 degrees. I replaced the angle A with what it was equal to, angle C. Okay, I hope that gives you an idea about substitution. Now you really can do one more thing I want to tell you right here. If I can squeeze it in, look at these two. I have angle A plus angle B is 30 degrees. I have angle C plus angle B is equal to 30 degrees. Both of these equal 30 degrees. Well, let's look at the equation at the top here again. I'm going to take this equation at the top and I'm going to replace the 30 What does the 30 equal? Well, if we look down here, we see that the 30 is equal to angle C plus angle B. So I'm going to begin writing the first equation up there. Let's see if I can write it right here. I'm going to write angle A plus angle B equals, but instead of writing 30, I'm going to write what 30 is equal to. It equals angle C plus angle B. Wow, we used the substitution property several times there. Now you notice that the reflexive property, the symmetric property, and the transitive property are also listed under congruence. So the explanation for those three are similar. I'm going to jump down here and explain to you that these three properties using congruence. Now congruence is when you are going to talk about triangles or line segments or angles. I'm going to just talk about angles or line segments right now. We'll save triangles for later. The reflexive property you'll think is silly. What it says is that AB, that's a segment, this is a line segment from A to B, is congruent to AB. That's it. That's the reflexive property. Or if you want to talk about angles, you could say angle C is congruent to angle C. Now later on you'll understand more about why we do that. I'm just going to tell you right now that I tell my students when you see something shared, then you're probably going to need to use the reflexive property. If I have this triangle, and we'll say this is C, this is angle C, well, if I make another triangle in here, the smaller triangle has angle C, this one right here, the angle, but then the larger triangle, this larger triangle, also uses that same angle, angle C. Well, we just have to make a statement in geometry that the two angles are really the same, and you can tell it in the diagram. That's how you would know that they are the same. And you can do the same thing with a segment. So it's something that is shared by two figures. All right, the symmetric property. The symmetric property, we've used it in algebra also many times. If I have a segment AB and it's congruent to, say, another segment, CD, we have two line segments that are congruent. That means they're the same length. I've got two lines that are both 3 inches long. You measure one that's 3 inches long, and I measure one that's 3 inches long. They are both the same measurement, so we say they are congruent. Well, a symmetric property says that it doesn't matter which way I write it. I can say that CD is congruent to AB. The transitive property. Now the transitive property is like a baby substitution property. If angle A, I'll just use angles this time instead of segments. You can use segments or angles in these. Angle A is congruent to angle X. But also I'm going to tell you that angle X equals something else. Angle X equals, say, 70 degrees. I could put degrees, or I could put another angle if I want to. Angle Y. Well, what do we know from this? This is substitution property. They like to give it a special name, so I can't really call it substitution. So I'll say baby substitution. You see this X? I'm going to replace it with what it's equal to. Remember, substitution is when you replace. Transitive property is very simple. You will have two expressions, and notice that I have an angle X in both expressions. One side will be exactly the same in both of them. And what we can conclude is that angle A would have to be equal to angle Y. That's the transitive property of congruence. So I should have written congruent on these last two. Sorry. Put the little squiggly in there so you know that it's congruent. But we do have a transitive property for equals. We just use numbers then. Now we are going to look at two postulates, and then we can finally get around to doing our proof that we started out with at the beginning. There are two postulates that you need to know in geometry at the beginning of your geometry career, and the first one is about segments, and the second one is about angles. The segment addition postulate. Notice that I have a long line segment here, AD, but I've also put points B and C on the line segment. So that means I actually have other segments that I can talk about. Now this line segment AD is really covered with points. There's points all over it. We just label a few of them, the ones that we want to talk about. So we have segment AB, I wrote that here, segment BC, and segment CD. If I add these three segments together, they will create the whole segment AD. That's the segment addition postulate. Now you have to have segments that are collinear. All the points are in one line in order to use this postulate. All the points that you're using have to be in one single line. AB plus BC plus CD equals the entire whole segment here, AD. But you can also just use part of it. Look at AB, then add just the BC. AB plus BC gives you the segment from A to C. And that's what I have written here. So we have one segment that is created from several segments. They are all in the same line. And we can add the parts to create the whole, is what I like to think of us doing. We're adding the parts to create the whole. Now we have the angle addition postulate, and the same idea goes with the angles. It is a little more difficult to think about angles. Now again, I have labeled these so they're more easily talked about. I have angle 1, angle 2, angle 3, but then I also have several other angles, angle AMR or BMT. I have the entire angle is AMT. Angle AMT. Can you follow that? And you can call it TMA. That's the angle that represents the whole thing. Angle 2 plus angle 3. Where is that? Angle 2 and angle 3. That would be angle BMT. Angle BMT. And you can say TMB. But you must keep the M in the middle because the M is the vertex for all of these angles. So it must be the middle letter. If you use 3 letters, then you must use the vertex in the middle. Well, I hope that helps you understand the segment addition postulate and then the angle addition postulate. Now let's try our proof. A proof is where you write statements. Oops, sorry about that. Statements. And then you always have to give a reason. And a reason is the properties or the postulates. So reasons are not really your thoughts. I know we reason with our mind, but when I say the word reason, and when your teacher in geometry says reason, they want you to give one of the properties. I'll write that up here. Properties, well, or the postulates. And later on, you're going to learn some other things called theorems or corollaries. So reasons have to be some of the properties or the postulates right now because that's all we know about. All right, our first statement is usually the statement of what's called the given, and that is the reason. It's what you started out with right here. The measure of angle XOL. Now that little M just represents measurement, and you're really supposed to use the little M if you use equal marks. If you use congruence, you don't have to. But some books don't use the M. Alright, so we have the measure of angle XOL equals the measure of angle YOP. That's the given information. Now step 2. Step 2 is where you start thinking. What am I going to do? How do I get to this statement here? This statement to prove is the last thing that we will have at the bottom. That's what we're trying to get to. Alright, well, let's look at the diagram. That's always a good second step. If I look at the diagram, what can you tell me about XOL? Well, angle, the measure of angle XOL. Do you see it? What does it equal? Well, XOL, isn't that angle 1 and angle 2? Sure, so it equals the measure of angle 1 plus the measure of angle 2. Now, your teacher may not make you write the little m. I'm writing it in. Some do require it. We are talking about the measurements, and you notice I did use equal here because when we talk about measuring something, we're talking about the actual degrees, the number. Alright, for number 2, the reason is, well, what did I do? Didn't I add the two angles together that created XOL? That was the angle addition property. We just talked about that. When you add the parts together to get the whole, so we're going to write that angle addition postulate. Now, some teachers make you actually write the postulate out. I like to just write the name. Alright, step 2, we're not quite finished because we're going to do the same thing with the other angle, YOP. Now, look at the diagram. What do you see about YOP? Well, it's equal to the measure of angle, 2 plus the measure of angle 3. And I'm going to put both of these on statement 2, so I don't have to write another reason. It's the same reason. Alright, both of these are on statement 2, and our reason for statement 2 is angle addition postulate. Alright, now then, do you remember the substitution property? Look at step 1 up there. Now I'm going to write step 3, but we're looking at step 1. Look at step 1. Remember how with the substitution property you can replace? Alright, XOL. What does XOL equal to? It equals angle 1 plus angle 2. So I'm looking at statement 1, but I am replacing things. I'm going to replace XOL with what it's equal to. Oops, I forgot the M. Alright, remember this is XOL equal, looking back up there at statement 1, I have equal marks, and it is equal to the measure of YOP. But guess what? I'm not going to write measure of YOP. I'm going to write what it's equal to. So I'm actually doing two substitutions. YOP is here. YOP is the measure of angle 2 plus the measure of angle 3. So this is our third statement. So guess what our third reason is? Reasons are always properties or postulates. What did I do? I did the substitution. I actually did it twice. We only have to write that once, though. Each statement has to have a reason, and we always number them similarly. This is statement 3, so this is reason 3. Okay, now then, look at this equation. We have a very long equation now. Look at the left side. Look at the right side. Do you notice anything about the left and the right? They both have a 2. Alright, step 4. Look at angle 2 up here. Angle 2 is shared. You remember the arcs I told you to look at? See this arc for XOL? Angle 2 is in that angle, but angle 2 is also in the larger arc. So angle 2 is shared. Now, which property did I tell you to use when something was shared? Do you remember? Can we find it? Did I erase it? Where was it? Oh, I forgot to write that important word. It's right here. The reflexive property. We have to use the reflexive property when something is shared. Alright, write shared. So, for step 4, I said angle 2 is congruent or equal, that is, to angle 2. We're using equal marks right now. That's reflexive. Okay, now the last step. Now how do I know it's the last step? Because we're about to get this last statement. Remember, we were trying to get angle 1 is equal to angle 3. Look at step 3 and step 4. Look carefully at those two statements, statement 3 and statement 4. Because we have angle 2 on both sides, that was my big clue right there. Angle 2 was on the left, angle 2 was on the right. And I knew angle 2 was in both of those angles. It was shared. So I am about to use the subtraction property. I am going to use the subtraction property. Now notice all of our reasons are properties or postulates, except for the given. And that was given to you. You can always write it. Subtraction. What are we going to subtract? We're going to subtract the 2's. We know that they are equal. Remember, you have to subtract the same thing on the left as you do on the right. Angle 2 is equal to angle 2. I can subtract angle 2 from the left. I'm looking at statement 3. And what will I have? I will have just angle 1. There, I forgot that M again. And now if I go on the right side and subtract angle 2 from it, I'll have the measure of angle 3. And we are finished. Because you see, that's what we wanted to do, was to prove that measure of angle 1 is equal to the measure of angle 3. Your first geometry proof. There's a similar proof that works with line segments that a lot of books like to give you. You'll have a line segment and there will be a segment that's shared. If we have, say, A, B, C, D. If I want to talk about BD, and then I decide, oh, but I want to talk about AC. What do AC and BD share? They share this portion. They share BC. So if you could do a proof with this one. Well, that's enough for today. This has been rather a long lesson. This is Susan Johnsey with mathinabox.com. If you have any questions, please email me.